We got to do this indefinite integral. And so how are we going to do it? This is really hard, all these x's everywhere, power something bottom. We're going to change it to a u integral, which will be much easier than do the antiderivative and go back to x in the end. You see all these answers, final answers back to x. How do we do it? Well, when you see an x to the third and an x squared, you're going to let u be the higher power because then the derivative, the du, will bring it down a level and will match that. Not only that, this is also the inside of a third power, parentheses to the third power. So you always let u be the inside thing. So I'm going to let u be x cubed minus 4, as you can see right there. So I'll write that up here. U is x cubed minus 4. So this inside right here, this will become u to the third power, right? Because it was x cubed minus 4 to the third power, and u is x cubed minus 4, so this is u to the third power. Now, let's take the derivative of this. Du dx. You remember derivatives, bring the 3 down. Subtract 1 from the power, and then the 4 just goes to 0. And then multiply both sides by dx. This cancels out. So du is 3x squared dx. So there it is, du is 3x squared dx. Okay, great. So what? Well, now we want to change the integral all the way over to u stuff. Well, how do we do that? See how in the top we have x squared dx, which is right here. So we just need to get rid of that 3. So that's easy enough. Multiply both sides by 1/3. And so we get 1/3 du is x squared dx. So wherever we see x squared dx, we can replace it with 1/3 du. Here I see x squared dx, so that's going to become 1/3 du. So this integral now, all the x stuff has been replaced with u stuff. So it's 1/3 du over u cubed. So there it is, 1/3 du over u cubed. So I'll write, yeah, I mean, they've got it right here. So there it is right there. Okay. Now I'm going to rewrite that to make it easier. So that is the integral of 1/3 times u to the minus 3, right? When you have u in the denominator, the 1/3 is just sitting there, u to the minus 3, right? That u to the third's on the bottom, it's u to the minus 3. And the 1/3 du is there. Okay, so why am I doing that? Because now we're going to integrate it. Now we're going to integrate it with respect to u. So, which means I'm going to do the antiderivative. I'm going to let this integral in the front and this du at the back together operate on this thing and do the anti. How do you do the anti? You add 1 to the power. So I'm going to keep the 1/3 in the front. I'm going to add 1 to the power, become -2, right? -3 plus 1, -2. And then divide by that 1. I'll put the negative there, like that, which is what we have here. -1/3 times 1/2 u to the minus 2. Am I losing you? You see what I just did there? I just took this and I did the anti. That's what the integral is saying. Do the anti, please. This is much easier than this mess in the beginning. Changing to u made the integral, the antiderivative, much easier. So you add 1, which made that -2, and then divide by it. I put the negative out there. Doesn't matter. You put the negative there if it bugs you. And then so there we go. There's that answer. And final step is now we change it all the way back to x. So we go, okay, it's -1/3 times 1/2. But then when we come to that u, what is u? Well, from the beginning, u is x to the third minus 4. X to the third minus 4. There it is. There it is. Plus a constant, of course. And there we go. So what happened? We changed this terrible looking x integral with a u sub. We let u be the part that's in the parentheses, the higher power. And then took the derivative, got that, multiplied by the 1/3. So we can replace the x squared dx with 1/3 du, and the bottom is u cubed. That became this integral. That we can do the anti of very easy. Just add 1 to the power and divide by that, and then go back to x. So we use the u sub to make the integral much easier.